E5 incline with pulley. So here we have a problem. See, you get problems look nice like this when you have your book. They'll give you stuff like that. And here, what we want to do is we want to release them, like you're holding these things and you release them. What's the acceleration in terms of G? Which way does it go? Does A go up or down when you release? And what is the speed of each mass after 1 second of the release? So what I did there is a little sketch. If I was doing the homework problem, see, I would do a little sketch here like this. And put in some parameters. They said this was 30 meters, and this one here was 40 meters. I will go ahead and emphasize that that's on the ground there, fixed. And then here, we have a rope going around a pulley. We have here, they call this B. I don't like to change notation. I want to respect the client, and the client wants to call these A and B. I would have preferred to call 1 and 2 like I did before, but I'm getting paid by the client in a theoretical sense. And it basically is saying here, that's also given in the problem, that MAG is 10 newtons and MBG gave the weights as 20 newtons. And it wants to know what the acceleration is. It wants to know, does A go up? And 3, speed after 1 second. And I'll just emphasize here, release from rest. So I think we have all the given in a nice way. And I'm going to go ahead and add a plus direction. Say this is plus for me. And if I get a negative when I solve, it just means A is going down, the incline instead of going up. So we're ready here for the force diagram, and there'll be 2, the force diagrams. You know, I like to keep this one slanted, that's my preference. And so this one here, up the incline is positive, and for mass 2, down is positive, to be consistent. So here we have MBG going down and T going up. Here we have T pulling, and this is MAG, and there's a normal force here. I'll just call it N since there's only one normal force in the problem. And this is also angle theta, as we saw that trick before. So then we come to Newton's laws, or the equations. Newton's laws. Newton's law equations. So this is T going up minus MAG sine of theta, opposing it, is MA. So that big A is the mass A. And then here, for the mass B, I have MBG minus T is MBA, and they move together, so the accelerations are the same. And then for solving, I used a trick where I add the equations together, and if I do that, I will get MBG, T's will cancel, and I'll have minus MAG sine of theta. And when I add the equations here, I'm going to get the masses are going to add times acceleration. So I almost have the solution here with symbols. And my preference is actually to do it with symbols, plug in numbers at the end. But that's just my preference. If you want to put the numbers in early, you can do that. So this is going to be, here, acceleration is going to be equal to mb minus ma times the sine of theta over ma plus mb, and there's going to be a g there. Dimensions check out. But now I find out if I want to put the numbers in, actually they gave me the weights. So if they gave me the weights, I really want the g inside. So what I'm going to do with this, let's go over here. I'm going to go ahead and put an mbg like this, minus an mag, sine of theta. I'm multiplying the top and bottom by g, and I'll have g there. They want it in terms of g. So the acceleration in terms of g, so that's actually ideal for all the things that they gave me, because they gave me this is 20 newtons. The first one is 10 newtons. So this is your 10, and this is your 20. And then the sine of theta, they were friendly here, because I recognize that this is a 3, 4, 5 triangle. So the sine of theta is 3/5. So the acceleration is going to be 20 minus 3/5 of 10, which is 6, divided by 10 plus 20, which is 30. This is 14 over 30, and I like this, 7/15. That's real cool. Very nice. So that's the first answer. And since A came out to be positive, we know the second answer. Okay, so we might just say this is answer 1. And then for answer 2, A is positive, so that means MA moves up incline. It goes up the incline because it's positive. The way I set things up, that's the positive. Then to find the speed, I'm going to use this equation. V is V naught plus AT. They want the speed after 1 second. So this is 1 second. And this is going to be 7/15 times G, 9.8. Starts out at rest. So that's the answer. And when you work that out with the calculator, you get 4.6 meters per second.